Hello and welcome to the course on the transmission of data packets, Ethernet. In this section, we'll look at the actual core components of data transmission with Ethernet, the Ethernet frame, and the MAC address. Have fun! We have often heard that Ethernet is a packet-oriented technology. This means that the data to be transmitted is split up into small data packets and sent that way. These data packets are also called frames or datagrams. Depending on the Ethernet standard being used, the frames are structured differently and may contain more or fewer data fields under certain circumstances. The first version of Ethernet, Ethernet 1, is still based on 16-bit data fields without defined bytes. Modern Ethernet frames started being used in the so-called Ethernet 2 structure, before Ethernet was further developed in the IEEE 802.3 standard protocol by the IEEE, starting in 1983. The frame structure was modified several times over the years, so the frames could carry more precisely defined information data. We can differentiate between the following Ethernet frames: Ethernet 2, Ethernet 802.3 RAW, Ethernet 802.3, Ethernet 802.3 SNAP, and tagged variants of Ethernet 2 and 802.3. The tagged variants were developed for VLAN use, that is, the Virtual Local Area Network. They have a special tag containing control data, which can assign the frame to a specific VLAN. A frame essentially consists of three subsections: a header, the payload, and the trailer. Depending on which Ethernet frame we look at in more detail, the individual composition of the header changes. Let's look at the two most commonly used frames, Ethernet 2 and IEEE 802.3, in the example. The type field, which comprises 2 bytes, contains information on the protocol of the higher level layer, which the receiver can evaluate. Ethernet 2 is uniquely identified by the size of the type field with a value of greater than or equal to 1536 bytes. Instead of the type field, this frame contains a field with a length of 2 bytes. It can be identified by the size of the length field of less than or equal to 1500 bytes. As the Ethernet frame does not provide an option for showing the receiver which protocol of a higher level layer is being used, according to the 802.3 standard, it requires an LLC header according to the 802.2 standard for conveying this information. Both frame types can coexist in today's networks. Ethernet 2 has advantages here thanks to its smaller protocol overhead. That's why we'll stick with this frame type and take a look at the individual fields in detail. The header is comprised of address fields and control information for controlling the data flow. MAC addresses are used as the addresses, which are the hardware addresses of the network adapters assigned by the manufacturer. For the MAC addresses, 6 bytes are available in each case. The destination address specification comes first, followed by the sender address. The type field then follows. This field specifies the next highest protocol, which is usually IPv4 or IPv6. The actual data area follows after this. The payload generated from the higher level layers is placed here. The entire Ethernet frame, that is, the header, payload, and trailer, must have a minimum length of 64 bytes. If the payload is smaller than 46 bytes, 64 bytes minus the 18 bytes of the header and trailer, the remainder must be filled up. Fields for the so-called padding bits, with which the Ethernet frame can be brought up to the minimum size, if necessary, are provided in the data area for this purpose. The Ethernet frame ends with a trailer. This contains the frame check sequence, or FCS for short. The FCS is a checksum according to the CRC method for verifying whether the frame also arrived correctly, so the receiver does not get faulty information. The receiver therefore has the option of using the FCS field to check whether the frame was transmitted fully. The checksum is calculated over the entire frame, beginning with the destination address and ending before the PAD field. By default, an Ethernet frame is also no more than 1518 bytes in size, of which 18 bytes are reserved for the header and trailer. In each case, 1500 bytes are available for the payload. If we use a tagged frame as per IEEE 802.1q to integrate a VLAN, the header is expanded by 4 bytes, giving the frame a maximum size of 1522 bytes. So, that was the individual meanings of the blocks. The Ethernet frame is surrounded by the so-called preamble, the start frame delimiter and the interpacket gap. These 3 blocks start and end the Ethernet frame, but they are not used on layer 2, as with the Ethernet frame, but rather on layer 1. The preamble is 7 bytes long, an alternating bit sequence of 0101, historically serves the purpose of synchronization and is almost no longer used today. The start frame delimiter, or SFD for short, is a 1 byte long field and always has the bit sequence 10101011. This bit sequence indicates the subsequent start of the actual Ethernet frame. A 9.6 microsecond pause occurs after the frame is sent. This pause is called the interpacket gap and represents the minimum time interval between 2 sent packets on the transmission medium. Now we know all the important aspects of the Ethernet frame. As we've already heard, MAC addresses of the sender and receiver of the data packet are contained in each Ethernet frame. Each network subscriber, in the form of a network card, possesses a unique key called the MAC, or Media Access Control address, and which makes it uniquely identifiable on the network. The IEEE 802.1 standard defines these Media Access Control addresses. The physical address for network interfaces, among other things, is specified here, regardless of the transmission technology. The so-called MAC addresses apply for Ethernet, IEEE 802.3, Bluetooth, IEEE 802.15, and wireless LAN, IEEE 802.11, for example. The MAC address is 48 bits or 6 bytes long and is represented in the hexadecimal format. The 6 bytes are divided into 2 blocks: the manufacturer code, Organizationally Unique Identifier OUI, and the adapter code, Network Interface Controller NIC. The manufacturer code is assigned to a manufacturer by the IEEE and comprises 24 bits or 3 bytes. The manufacturer, on the other hand, assigns a globally unique adapter code also comprised of 24 bits or 3 bytes, with which each individual manufactured adapter can be uniquely identified. In fact, MAC addresses are issued multiple times in some cases, but manufacturers try to avoid local collisions through geographical separation. As MAC addresses are modifiable, it must be ensured that the same address isn't used twice on the same network, as otherwise unique identifiability is no longer ensured. Let's take a closer look at this MAC address. 00, 1B, 1B, CB, AC, E4. We divide the address into 2 times 3 bytes. Beginning with the 3 bytes on the right, we see the adapter code. The 3 bytes on the left stand for the manufacturer code. This character sequence identifies Siemens AG as the manufacturer. The 3 bytes on the left stand for the manufacturer code. The highest value byte in a MAC address identifies the category of the MAC address. B8 equals 0, a unicast address. For example, 08, 00, 05, 01, 02, 03. B8 equals 1, a multicast address. For example, 01, 00, EF, 01, 02, 03. B7 equals 0, assigned only once in the world, OUI. B7 equals 1, locally managed MAC address, assigned logically by a manufacturer and with no global meaning. We have learned about the Ethernet frame and MAC address. Now it's time for a brief summary. We wanted to know, what is an Ethernet frame? We've learned, with packet-oriented technologies, data to be transmitted is divided into small data packets, which are also called frames. Depending on the Ethernet standard being used, the frames are structured differently and may contain more or fewer data fields. We wanted to know, which important Ethernet frames can we differentiate between? We have learned Ethernet 2, Ethernet 802.3 raw, Ethernet 802.3, Ethernet 802.3 snap, and tagged variants of Ethernet 2 and 802.3. We wanted to know, what subsections make up a frame? We have learned header, payload, trailer. We wanted to know, what is the length of an Ethernet frame? We have learned, an Ethernet frame must be at least 64 bytes in size and can reach up to 1518 bytes. If a VLAN tag is used, it can even be 1522 bytes. We wanted to know, what components flank an Ethernet frame? We've learned, the Ethernet frame is surrounded by the so-called preamble, the start frame delimiter, and the interpacket gap. These 3 blocks start and end the Ethernet frame, but they are not used on layer 2, as with the Ethernet frame, but rather on layer 1. We wanted to know, what is the MAC address? We have learned, each network subscriber in the form of a network card possesses a unique key, called the MAC or Media Access Control address, and which makes it uniquely identifiable on the network. We wanted to know, how is the MAC address structured? We have learned, the MAC address is 48 bits or 6 bytes long and is represented in the hexadecimal format. The 6 bytes are divided into 2 blocks, the manufacturer code and the adapter code. The manufacturer code is assigned to a manufacturer by the IEEE. The adapter code is issued by the manufacturer and must be unique in the world.